My name is Higgs and this is my friend Boson. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Boson?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Regional Assessment of Carbon Pool Response to Intensive Silvicultural Practices in Loblolly Pine Plantations.
Forests sequester CO2 from the atmosphere at a rate equivalent to 10% of global anthropogenic CO2 emissions. The majority of this carbon sequestration occurs in unmanaged forests, where trees establish and grow in response to natural processes.
Tree plantations represent an important component of the global carbon cycle and are expected to increase in prevalence during the 21st century. Silvicultural practices are generally used to increase forest growth, making it possible to align management with increased forest CO2 uptake and carbon storage.
That is so intriguing, Boson. Researchers examined how silvicultural approaches that optimize economic returns in loblolly pine plantations affected the accumulation of carbon in pools of vegetation, detritus, and mineral soil up to 100 centimeters across the loblolly pine's natural range in the southeastern United States. Comparisons of silvicultural treatments included competing vegetation or weed control, fertilization, thinning, and varying intensities of silvicultural treatment for 106 experimental plantations and 322 plots.
The average age of the sampled plantations was 17 years, and the carbon stored in vegetation averaged 82.1 ton of carbon per hectare and 14.3 ton of carbon per hectare in soil organic layers, coarse woody debris, and soil detritus. Mineral soil averaged 79.8 ton of carbon per hectare across sites.
That is a very interesting observation, Boson. From these data, researchers constructed regression models that summarized the carbon accumulation in detritus and detritus combined with vegetation, in response to independent variables commonly monitored by plantation managers. These variables include site index, trees per hectare and plantation age.
To conclude, a general recommendation for managers looking to maximize carbon storage would be to maintain a high trees per hectare and increase site index, with site index manipulation having a greater relative effect.
Notably, site index can be increased using both genetic and silviculture technologies. That was an interesting paper. Hope you liked it, Boson.